Hi, let's start task and functions. We already discussed the task and functions in Verilog. We have the same difference, like function does not consume any time related parameters. Inside task you can use timing related things. Then inside a function you can't able to call a task. Okay. And task can call function as well as tasks. This difference we already know. Here in system Verilog, there is some updation happens in the functions. Okay, let's see those things here. Okay, subroutines implemented using task and functions. Okay, some set of code if you want to use frequently in the module, you can write those set of statements inside the function or a task. Then we can call that those lines with the help of task name or a function name. When user want to execute repeated functionality, they are implementing as task or a function. Task is time consuming and function does not consume time. Static and automatic tasks and functions are there that we will discuss in the forthcoming slides. So this is the difference compared with the Verilog function and the system Verilog functions. Okay, in Verilog, return happens using function name. Okay, the output value we are assigned to the function name. The function name is going to act as an output variable in the Verilog. Here in system Verilog, the same way you can do, and also you can use return keyword. With the help of return keyword, you can able to return the output value to the function. Then here in this how we are using the task, in the same way we can also use the output argument in the functions. Okay, that we will see with the example. Then static function and task. Okay, those static function and tasks are always used to access the static variables and do the job that is common for all the instance of class. This point also we will discuss with the example. Let's start with the task. A task can contain a declaration of parameters, input argument, output argument, in-out argument, registers, events, and 0 or more behavioral statements within that. Task and task implies a begin and end structure. In Verilog, we need to use begin and end within the task. Okay, but here the task and end task itself act as a begin and end. Okay. The default direction is input. So if we mention the variables inside the list of a task, default those are the inputs. Task can be a static or automatic. Static means share the same storage space for all the task call. Automatic means allocate unique stacked storage for each task call. That is the difference between static and automatic. This also we will discuss with the example. So first we'll explain about task. Okay, let's take this example. So within this module, I created one task sum, input int a, b, and output int c, and c equal to a plus b. This is the functionality. For this functionality, I wrote down task with the name of sum. Within this initial block, I want to perform sum of for the 10 and 5 values. So I passed those values here, 10, 5. So it is assigned to the input variable a and b here, and then output is mapped to x. So here I receive value 15. Okay. So this is the one way of writing task. Another way you can also write like this: task name. Within this list, you can mention input, and you have to declare the inputs along with the data type and output along with the data type. Okay. Instead of mentioning here, you can also mention this list, and you can just pass the values. It will map to A, this is mapped to B, and X is mapped to C. So we will get X value here, and here we are displaying that one. Okay, this is one example for a task. Value of X is 15. Then we move to functions. Function cannot contain any timing control statements within that, and they cannot enable task. It cannot call a task. Functions can return only one value, that may be with the return keyword or the function name, or with the help of output argument. In three ways we can able to pass the output. Then function end function implies begin and end structure. Here no need to explicitly mention begin and end for the function between the function and end function. Okay, no need. And it support return type of void. So void is a keyword along with the function name. If you mention void, it indicates that there is no return type. Okay, the function will not return anything. It will just perform operation, or it will just display the values. Okay. Let's see one example for function, then we will discuss about static and automatic functions. Okay. So module, end module. So these are the different ways to write the functions in system Verilog. So this is the way you will write in Verilog. Function, okay, function name. Here the function name is going to act as a output variable, so it should capable to store the int inputs. Okay, so it also declared as a int data type. Then input int AB. So if you perform addition, here we are performing the addition and we are putting the value to sum. It is nothing but the function name. So this is the one way. The another way, with the help of return keyword. Function int sum, then input int AB, return A plus B. So it will perform addition and it returns that value. Here we can able to get that value. It will and it will be assigned to X. Here also the sum will return. It will give the value for A plus B. It will be assigned to X. Here and here we are displaying that X value. And this is the another way, the help of output argument. Okay. So output int C, it is similar to task. Okay, how we are doing task in the same way, input argument and output argument, and output equal to A plus B. Here if we give like this, you can able to pass the inputs for A, B, and you are getting the output C here with the help of X in type. Okay, and we are displaying that value of X here. X is 15. Then I told, right, static and automatic. Let's take this example. Here this is the module and this is a class. Okay, class is dynamic in nature. Okay, so if I declare a class like this, there is no memory created for this class. It is a virtual thing. Okay, the name of the class is base main class. Within that I just write on function, on method function static get. Okay, inside that I declare a variable as int and I am incrementing the value of A one time and I am displaying the value of A in decimal. Okay. Here this is a static property, sorry, this is a dynamic property. There is no physical memory is allocated for this class. Okay, that is the behavior of class. Okay. So module, inside the module, okay, within the initial block I just instantiate that base class. The base is the class name. With the help of that class name. I instantiate here B1. B1 represent this base class. Okay. New of is a method used to allocate memory for this B1 instance. Okay. When you give base B1 equal to new, I will explain with the diagram. Okay, base is a class. It has a function in it. Okay. So when I instantiate base as B1, it is just a instance. When you create new of, memory will be allocated for this B1 instance. Okay, this is the actual one. It is a virtual one. Now actual physical memory is allocated for this base, and it is referred with the help of B1. Okay. And in the same way, base B2 equal to new of. Okay, when I do like this, another instance B2 instance, it is created, and with the help of new of, I am creating. It is creating in another memory. This is created in one particular memory, and it is created in another particular memory. Okay. Then here the thing is, we are going to see about the static keyword. Okay. Function static get. If I give like this, the variable inside the function will be behave as a static variable. Okay. So static variable in the sense, just go through the point which I explained for static. A common memory will be created for that variable. Okay. So A is a variable which is present inside the function. When I declare the function as a static here, a common memory will be created. Okay, this is the actual memory will be created for variable A. Okay, it can be able to store 32-bit. It is an int type. Now, when I call this, how I can access the method or a function inside the class, okay, with the help of this instance name B1. B1 representing this instance name. Inside that B1 dot get I am calling. Okay, this function will be available. This is available in the base class. Okay, we are instantiating here. So this actual class, this actual instance has that get method. Okay, so when I access that B1 dot get, the get method will be called. So there, what we are doing, we are incrementing the A value by 1. So here the A value will be incremented by 1. So now value of A is 1. Okay. So where this A is actually present, it is present here. Okay, when I make this as 1, here also it will become 1. Okay. Then next time, so see here, B2 I created, right? This A also pointing to the same location, because here the variable is static. This storage is allocated in a common location. Okay, so all these A are pointing to same location. Okay. Here also the A value will be 1. Then again I am calling B1 dot get. Again I call this function which is present here. If I call this, already the value of A is 1. Now the value of A become 2. Okay. So that here also it is 2. This is the actual value of A. We just referring this point, this A and this A are pointing to this A only. Okay, so here also the value of A is 2. Now in the 16th line, B2 dot get off. I'm calling the method get which is present in the B2. Here also I have that get method, right? So if I call this, again the A value get incremented. So here also the A value is 2 now. It is get incremented as 3. Here also it will be 3. Okay. And this here also it will reflect, right? A is the is there in the common position. When you change here, it will actually change here. Okay. When you change here also, it will actually changing here. It just these A's are pointing to this location. Okay. So if you see in the display, when I call b1.get, first time a value is 1. Second time when I call, it is get incremented, so 2 I am getting. Third time when I call, again it gets incremented, so I am getting 3 here in the output. So this is the use of static. Okay, if I remove this static, now each time when I call, okay, a new memory will be created. So each time when I call, it is in this default state 0, so it will increment it by 1, so I am getting 1 1 1 1. Okay. Okay. Next, then one more difference. There's a difference between static function static. So here I explain about function static, right? So if I mention function static, the variables which is present inside the function will behave as a static variables. When I represent as a static function, okay, the variable will not behave as a static variable. Okay, only the function is static. Each time when you call in different instance, this same function will be called, but the variables will not be a static. That's the difference. Okay, next, automatic function. Okay, here I'm going to find the factorial of a number. In this initial begin block, with the help of for loop, I am assigning value for this n. Initially it is 0, then 1, 2, 3, 4, up to 4. I am assigning value for this n. Okay, this factorial is nothing but a function. I wrote it here. Okay, you can label the function like this with the help of colon after the n function. Okay. Here, let's see inside the function. Okay, function automatic integer factorial. This is the function name. It has to support 32-bit of integer type, so I declare the integer because here the factorial is going to act as a output argument, right? Then here I use the keyword automatic. That's I already told, when you mention as a automatic, a unique memory will be created in the stack order. Okay, let's see that part. Here input operand, 32-bit operand I am getting, and I am checking whether it is greater than or equal to 2. If it is greater than or equal to 2, factorial equal to this output equal to factorial of operand minus 1, that is previous value, factorial value into operand. Okay. Else factorial is 1. Okay. First in this iteration n value is 0. Okay, so factorial of 0, 0 I am passing here. Okay, it is checking here, it is false, so choose the else part and the factorial is 1. Okay. And next time n value is 1. We are passing 1 here, it is checking here, it is false, so this time also factorial is 1. When I pass 2 here, this check here, it is satisfied, so factorial equal to factorial 2 minus 1, that means factorial of 1. So factorial of 1 value is 1. Okay, here this function calls its own function, recursive function. Okay, function calls its own function. Okay, of factorial of 1 into factorial of 1 is 1 into operand 2, so we will get 2. Okay, the same way for 3 value we pass, it will check this condition, here factorial equal to factorial of 2. So what is factorial of 2? That is stored in a stack, as like a stack structure. You see here, okay, when you use this automatic keyword, okay, a unique memory will be allocated in the stack order. Here you have the value of factorial 1, it will access easily and it will perform. Okay. And for factorial 3, I need the factorial 2 value, so it will access from it. Okay. So for this type of operation, we can use this automatic keyword. Okay. So if I didn't mention the automatic here, it will behave as a normal function. So it will not able to access which is factorial of 2, which is factorial of 1. So each time when I call, I will get a factorial as 1. Okay. That means different here if I mention just a function, it is similar to automatic function. Okay. That means it is what I explain is a function automatic. If I didn't mention that, default this function is dynamic in nature, that is automatic in nature. That means the memory will be created newly in different positions, okay, not in a stacked manner. So that the function call its own function, that is f of 2 wants f of 1 and f of 3 wants f of 2. So in that way it will not able to access. Okay, so we are getting factorial as 1. When you mention this automatic, then only the stacked memory will be created with the unique locations, and you can able to access those things. Okay. Then the function and task argument passing can do in 4 ways. One is argument passed by value, argument passed by reference, argument passed by name, and argument passed by position. That we will discuss with examples. Here this is passed by value, okay, module argument passing, and in module within that I wrote on function int sum, int xy. Default it is an input. If I didn't mention anything, it is an input. X equal to x plus y, return x plus y. So here I assign value of x and y. And I am passing this x and y to this sum function. So x is 20 and y is 30. Here it is added and it is 50, right? So 50 plus 30 is 80. Okay, it is written here, and z value is assigned as 8. So 20, 30 and 80 is the expected output. Okay, that we are getting. Okay, this is the pass by value. We are directly passing the values. We are getting the output here. Then pass by reference. Here in pass by reference, we are using the ref keyword in the function. While declaring the inputs, if you use ref keyword, it is called pass by reference. That means here this input xy will be treated as a reference, and if there is any change happens here, that will be reflected output of the function. Okay, this will be act as a reference one, so that will affect here. Okay. I'm assigning value 20 to x and 30 to y. Okay, here I am passing those values. 20 plus 30 is 50. Okay, x value is 50 here. So 50 plus 30, it is 80. It is returning 80. So z is 80 and y is 30, and x value will be here. It will be 50, because here the value of x varies. Here I pass 20, but inside the function I mentioned ref, and here the x value changes to 50, so it is the reference one. So now the value of x is 50, that will affect outside the function also. So when I print x value here, you will get 50. That is the use of ref keyword here. It's called pass by reference. Okay. And then pass by name. So we use this method. You can mention in any order, because here we are mapping the names. Here for y I map this hello world, and for x I map this 2016. With the help of this dot, I map the value for the corresponding variables. Okay. So here I just display the value of x and y. Y is hello world and x is 2016. I am getting. Okay. Then next is pass by positions. Okay. So here we are going to discuss default values also. Position in the sense, if in this case you can mention in any order, because we are mapped for the particular signal. Okay. Here this is passed by positions. You need to pass value to the appropriate positions inside this function. Okay, we have three input variables x, y, z. Here I assigned x as 5, y as 10, and z as 20, and I am returning the addition of x, y, z. Here if I mention like this, if I didn't pass any value, it will take its default value. X default value is 5, and y's default value is 10, and z default value is 20. If I pass here, this example q equal to sum of, I'm calling the sum function, and I am passing nothing here. On this location I didn't pass anything, and 10 I am passing. This 10 will be override this 20, so instead of this z, 10 will be assigned. Okay, so 5 plus 10 plus 10, you will get 25 for q. You are getting. Okay. So these are the ways we can pass the values as an argument to the function or a task. Okay. So the remaining thing we will see later. Bye.